All right, good afternoon. Hope you had a great day today. It is going to be section 4.8, least common multiple, which we often call the LCM. We are talking about multiples, so that's the first thing that we're going to discuss. First of all, why don't you go ahead and hit pause and copy this information down. So go ahead and do that. So going back to the word multiple, okay, that is again the product of a number and a whole number. You can also call it by saying that you're going to count by the same number. So example, the multiple of 3 would be 3, 6, 9, 12, which is the same thing as saying 1 times 3, 2 times 3, 3 times 3, 4 times 3. Obviously, the next one is 5 times 3, so this would be 15, and so on. Those are multiples. Many times we get multiples and factors confused, especially when we were given, for example, the number 12, and we're asked to find the common multiples of that. Many times we want to say, well, it's going to be 1, 2, 3, 4, 6, and 12. What are these called? They are factors of 12. Okay, we do not want this. We are talking multiples, so it would be 24, 36, 48, and so on. Okay, multiples, counting by that number. When they say the least common multiple, that is when we're going to compare the multiples of two numbers. So the least of their common numbers, and again excluding 0. So we would be looking at, for the 6, we'd be 6, 12, 18, 24, 30, 36, and so on. And when we look at these, we see that the 24s are the first numbers that are common. This one would then be 40. Oops, I'm sorry. 42. And then the next one would be 48. This one would be 48. So the common numbers would be 24, 48, and so on. And actually, if you want to find the next set of common multiples off of this, it would be the multiples of the common multiples. So if you want to find, let's say, the next 3 common multiples, you could start with finding the least common and then do the next 2 multiples of that. Okay, so then 24, then 48, and then 24 on to 48, giving you 72. So then 72 would be my next common multiple for 6 and 8. Okay, but we are most concerned with our least common multiple. Okay, least common multiples, where are they used? Well, where do we use least common multiples? We actually use them, we change the name to least common denominator. That's where we use them most, when we are trying to find common denominators in fractions, when we compare them, put them in order, and then when we add or subtract them. So that's the use of what we are trying to find here today. So let's go ahead and look at the next one. This is another method of finding the least common multiple using prime factorization. It's confusing. We've decided not to use that. So you might see it in the book. It gets very confusing with the way you do greatest common factor using prime factorization. So I think the best method, again, is to simply list our factors, or list our multiples. Even I get tongue twisted with that as well. But again, we're going to list our multiples and find them in that manner. So what I want you to do is go ahead and do that for letter A, 7 and 9, list the multiples, and then see what you can find for our least common multiple. Go ahead and do that. So I have 7 and I have 9, and I'm just going to start with those two numbers. And so we'll count by 7, so 14, and then 21, 28, and then 35. I like to list about 5 of them first and then look at my other numbers and see what I come up with. So I get 9 and then 18, 27, 36, 45, and that gives me 5 of them. And I see that I've surpassed this and I still don't have one. So I could go a little bit further to 54 and then 63. And then I'm going to play catch up with this over here to where I have 35 and then 42 and then 49 and then 56. And then I see that I get 63. And that is definitely my first one that is common, therefore that is my least common multiple. Now some of you might look at this and say, well, all I had to do is multiply 7 times 9, that gave me that answer. It won't always give you the least common multiple. Will it give you a common multiple? Absolutely, but it won't always be the least common, so be careful with that. Now let's do 3 numbers that we're going to compare. So go ahead and do that. So now I have 15, 18, and I have 30. So I list those multiples, and a little shortcut to all of this, especially when we have all these larger numbers, my answer will never be smaller than my largest multiple or than my largest number. Okay, so why don't you start with the largest number, 30? And if you want, start with 30. And does 15 or 18 go into 30 equally? Well, 15 does, 18 does not. So do the next multiple, 60. And does 15 go into 60? Yes, it does, 4 times. Does 18 go into 60? Well, if you're not sure, go over here and 18 times and take a little guess at it. And I would say maybe 3 times, which is 24. And that then gives me 54. So that's not going to work. That doesn't go into it. So the next multiple, which would be 90. 15 goes into 90 equally. Let's try 18, and we'll say 18 times, let's say 3, that's 24. Whoops, I'm sorry, not 3, 5. So let me back this up. We'll start over. 18 times 5, and we get 40, and then 9, so we get 90. So both of them do go into 90. That's an easy way of going through this and realizing what works and what doesn't, and what goes into it. Because if I were to list all my multiples of 15, that'd be 15, 30, 45, 60, 75, and then 90. And then for the 18, listing all of those out to get my 36, and then 36, 18 times 3, we already did that, so we get our 54. And then adding 18 more onto that, and you again can go over here and do all of this work over here to get my 72. And then when you add 18 onto that, you see this is the 5th one, and you get 90. So therefore, all of them do match up. Okay? But again, I like the shortcut method. It works really well. It works really well when we're comparing denominators as well and trying to find that common denominator. Start with the larger number and keep doing multiples of that number until the other two can go into it. So let's look at our next one. 25 and 30. Go ahead and hit pause and solve this. You're certainly welcome to use either method. So we have 25 and 30. Okay, so again, start with the larger number and we'll go to 60. Does 25 go into 60? It does not. So then we try 90. And does 25 go into 90 equally? It does not. So then we try the next multiple, which is 120, and that one does not. So we try 150, and since 25 would go into 150 equally, that is my least common multiple. So 150 would be my answer. Okay. Again, if you're not sure, you can list them. You get 50, 75, 100, 125, and then 150. Either method works perfectly fine. Okay, these are the types of problems that at your level we are wanting you to get to the point to where you're doing it not necessarily all mental, but we can certainly take these shortcuts for you to be able to do it a little more quickly, and you're still doing it accurately because you do know your factors and know them pretty well. Go ahead and do letter D. So we have 14, 21, and 42. We're going to start with the larger number, which is 42. And I'll let you go ahead and hit pause and solve this. So we take the 42 and do the next multiple. Well, before we even start that, let's look and see. Does 21 go into 42? It does, twice. Does 14 go into 42? Well, let's try 3 times. And this would be 12 and 42. Right there it is. So we already knew, without even having to do any more of these multiples of 42, 21 went into it twice and 14 goes into it 3 times. So we already knew right away, and that will happen frequently at times, especially when we have when we're trying to find common denominators. So go ahead and write down any questions that you might have, and we'll answer them tomorrow in class. Have a great night.